Now we're going to take up one more problem on the shaft. The problem number 19. It reads as: compare the weight, strength, and stiffness of hollow shaft of same external diameter as that of solid shaft. The inner diameter of the hollow shaft is half of the external diameter. Both the shafts have the same material and length. So D will be equal to D naught and Di will be equal to half into D naught, which will be equal to 0.5 D naught. LH will be equal to LS, tau H will be equal to tau S, and WGS will be equal to GH, and WS, small ws will be equal to some small WH, which is a material. So comparison of weight. So as we are considering, weight will be equal to volume into specific gravity of the specific weight of the material. So what is volume? It is area into length into specific weight of the material. So WH by WS will be equal to, so area is pi by 4 into D naught square minus Di square into length of the hollow shaft, that is small LH, into specific weight of the material is small WH. So divided by weight of the solid shaft, again area pi d square by 4 into length of the solid shaft, which is small ls, into specific weight of the material is the small wh. As we know that LH will be equal to LS and WS will be equal to WH, it cancels. Therefore, pi by 4 get cancels. Therefore, D naught square minus Di square by D square. So now D naught square is taking the common factor into 1 minus Di by D naught the whole square divided by D naught square. So it gets, because D will be equal to D naught, so D naught square will get cancels. So 1 minus 0.5 square, because Di by D naught equals 0.5. So that will be equal to 0.75 is the comparison by weight. So WH by WS will be equal to 0.75. Now comparison of strength. So torsion strength is given by T by tau will be equal to Zp, where Zph by Zps will be equal to pi by 16 into D naught to the power of 4 minus Di to the power of 4 by D naught. The whole thing is divided by pi d cube by 16. So pi by 16, it gets cancels. Taking the common factor, which is D naught to the power of 4 into 1 minus Di by D naught whole to the power of 4. And that D naught will come down, which was in the denominator here, which will comes down into D cube. So substitute the values D naught to the power, since D naught is equal to D, so D cube into 1 minus 0.5 to the power of 4 by D cube. So both these two will get cancelled. So it will going to be 1 minus 0.54, 0.5 whole to the power of 4. So on simplification, you will going to get it as 0.9375. That is D naught is equal to D. Therefore, the torsion strength of the hollow shaft divided by the torsion strength of the solid shaft, which will be equal to 0.9375. And similarly, the comparison of stiffness. The comparison of stiffness, that is the torsion stiffness of the hollow shaft divided by the torsion stiffness of the solid shaft, which is GH into JH will be equal to GS into JS. So as we know that GH will be equal to GS, therefore it will get cancels, therefore JH is equal to JS. So what is polar moment of inertia of the hollow shaft, which is pi by 32 into D naught to the power of 4 minus Di to the power of 4 divided by pi d to the power of 4 by 32. So pi by 32 will get cancelled. Therefore, D naught to the power of 4, taking the common factor of D naught to the power of 4 outside the bracket into 1 minus Di by D naught whole to the power of 4, and close the bracket, divided by D to the power of 4. As we know that D naught is equal to D, so D to the power of 4 into 1 minus 0.5 to the power of 4 divided by D to the power of 4. So D to the power of 4 in both in the numerator and as well as in the denominator, it gets cancels. So it will be equal to 0.9375. So as D naught is equal to D. So this is how you will be able to solve this particular problem. Thank you.